about how to use Git and why you should care. Git is a version control tool. You're probably familiar with something like Google Docs or Dropbox, other things that let you, share versions of things and keep track of the changes you've made to different documents. The thing about GitHub is that it's optimized for code, and it gives you a huge amount of control over exactly what changes you keep and what changes you get rid of and whose changes you incorporate. So that's the big why of why you'd want to use Git, because you can't really code very well in Google Docs. It doesn't, you're limited to that interface. It's a little bit harder to incorporate, like, okay, someone made this change and then someone else made this other change, and you want to keep the first half of the first change and the second half of the second change and have everything else stay the same. And Git lets you do those things, extremely precisely. And so if you're working in software, it's pretty common to use Git at work. And it's pretty much the best way to do collaboration on software. There are a few other version control tools that you could use instead, but something like this is going to be necessary because, again, Google Docs doesn't really cut it when you're trying to write code collaboratively with other programmers. We had this recent XKCD that was pretty relevant. So hopefully by the end of this presentation, it will be clear, a little bit clearer, not just a list of commands that you can run to get everything to work, but a little bit more of the rationale behind why these commands work. So let's jump into how we actually use Git. And actually, I'm going to briefly pop over here. If you have your laptop, you want to pull it out and open up the CS50 IDE. We're mostly going to be working in the terminal, not so much, that we'll only be doing a little bit in files. So what you're going to want to do, just to get set up here, is first you're going to open your SSH key file, the public key file. I don't know if you've talked very much about SSH keys, but what you want to do is this, okay? And it will pop up this long string of characters, and you just want to copy them. You want to copy the whole thing, so you can just do that. And then if you go to your profile on GitHub, you can go to Edit Profile, and then under SSH keys, you're going to add an SSH key. And you can title it CS50 IDE. Does that make sense? Did everyone get that step? This is just so that then when we're using the repository in the IDE, we can access it directly and not have to worry about typing in our password every single time we use it. Okay, so now I'm going to close that. If anyone else wants me to add them to the GitHub repository, if you just got here, I can do that now. If you have a GitHub account and you haven't told me your GitHub username, now's the time. Nobody? Okay, then I will continue on. All right, so first, let's talk about how a repository works. You have a remote public repository. This is what I was just showing you on GitHub. I created a repository. It's hosted somewhere on GitHub servers, and it's public. Anyone can see it. Then what we're going to do is we're going to create a local private version of it on our individual computers. And in fact, you can have many of those that all point to the same public repository. And in fact, it's also possible to have multiple public repositories that you get some information from here and some information from here, but that's unlikely to be relevant for your final projects or whatever, so I'm not going to go into that right now. But so how do you get from having this remote public repository to actually having that local copy? You use a command called git clone, which literally just means make a copy, as it sounds like. And so what you're going to do is go to the repository page on GitHub. You're going to copy the clone URL, the SSH clone URL, because we just set up SSH keys. If you don't have them, you can click instead on HTTPS, and you can use that. And then in here, in your workspace directory, you can do git clone, and then paste. When it asks you if you want to keep doing it, then say yes. And now, if you'll see, there's a directory with the name of the repository, how and why, for the seminar. And if we list the files in here, you can see that they're the same files that are listed on the web page. So now you have a local copy of the repository. Let's say you want to actually make changes to it. All of your changes in Git are stored, like the fundamental unit is called a commit. And a commit is just a chunk of work that you've put together and you've told GitHub, I want to save this as, I'm saving my work, essentially. And it's identified by what's called a commit hash, which is basically just a unique ID. But the way it's generated is actually GitHub has some format of like recording all of the changes that actually went into that commit, and then it hashes that record of the changes. So the commit hash actually tells you what happened in that commit, what changes you made. So to do a commit, let's go in here, and if you just open up the file names.txt, which you can do from the command line with open names.txt, and it will pop up here. Then you can add your name and then save it. And now, if you type git status, you can see that the file names.txt was modified. So Git knows that you made a change. Nothing's been committed yet. So to tell Git, this is a file that has changes in it that I want you to actually save, you do git add names.txt. And now, if you do git status, you'll see that it still hasn't been committed, but now it knows that this is a change that you want to commit. Basically, what's happening is you have your working directory, and Git has an index of what's happened to the working directory that is ready to be committed. And so when you make changes, they're in your working directory, they're on your computer, but they haven't been put in that index yet. And so when we do git add, it moves things from the working directory. Well, they're still in the working directory, but it copies all those changes into this index. And so then when you do git commit, which is the next thing we're going to do, it actually commits them and puts them in the permanent history of your repository. And when you commit, you should always put an informative commit message. So now, if we do git status, it says there's nothing to commit because all of the changes that I made have now been committed. All right. I'm going to throw away the accidental changes that I made to that. All right. So now you can see, let's say we essentially just made the purple commit, right? So we're just adding it on the end of this history that previously when I made the file, names.txt, when I first created it, maybe that was the orange commit. And so then this commit hash underneath the purple diamond would somehow indicate, not in a human readable form, but would somehow indicate to GitHub's internals that we made this specific change to the file names.txt. So now you have a change on your local private version of the repository. Now, you see the arrow goes both ways, and obviously it wouldn't be very useful if we could only ever pull, but if we could only ever like take the changes that were in the remote repository, but we had no way of making our own changes. So we want to push our changes to the remote repository. But before you push your changes to the remote repository, you always have to pull to make sure that there haven't been any new changes in the time since you first made that change. So we're going to do git pull. And it says already up to date, because presumably none of you pushed while I was doing this. But so now I can do git push. And now, if I go here, I can see that the most recent commit is this one that I made. That change is now in the remote repository. So anyone who has their computer out, go ahead and add your name. Make sure to pull before you push, and then push to the remote repository. So we should be able to see. So the reason that you always want to pull before you push is because if you try to push and you don't, and you're missing some commit that's on the remote server, it'll just give you an error. But if it didn't give you an error, it would overwrite what the previous person had pushed, and you don't want to lose their work. So let's see. Has anyone gotten this working, or having?
I'm having trouble pulling it down for some reason. It keeps saying that.
What happens when you?
One behind, and then when I try and push, it's just giving me an error.
So so you're having trouble pulling. What does the error say when you try to pull?
There is no error when I pull.
There's no error when you pull.
Yeah.
It doesn't say anything when you pull?
I'm using source tree because I don't have access to the ID.
Okay. So I don't know very much about your specific environment that you have right there. But so what's the error that you get when you try to push?
I'm getting a conflict error.
Okay. Try git pull origin master. So like this.
I think the problem is like he's using Windows environment, so he doesn't have a terminal like that with that master.
Again, I don't know very much about his development environment specifically, but when I've just been typing git pull, that's a little bit of glossing over exactly. You would normally tell, or you might not normally, but you can tell Git exactly where to pull from. So what remote server to pull from, because like I said, there could be more than one, although not usually in just sort of everyday development practice. And we'll talk in a little bit about branches. That's actually the next place we're going. And so master would be the name of the branch. Does that help? No, still not working. Has anyone else gotten it working? Okay. So I can pretend that I'm an extra person, but you're going to have to give me a second to get that set up. All right, so what I'm doing is I'm cloning the repository onto my computer. But first, I have to add another set of SSH keys so that I can do that. Okay, so now,
Can I ask a quick question?
Yep.
So the green dot next to some of them, what does that
next to the SSH keys, that just means that I've used those SSH keys recently. So let's do the same thing.
Now it worked.
It worked now? Okay.
It looks funky. I think I may have had a conflict when I was trying to pull down your change version with mine, but
Okay. So now if I open names.txt, I should be able to see. So you had to revise a conflict. All right, so let's just get rid of. Let's just get rid of these, because these we'll talk about merge conflicts in just a sec. But this is why you always want to make sure that the pull worked before you try to push and fix any conflicts before you push. Okay. But so here's an example of what you would then do. If I go into here, make sure that I have the most up-to-date changes. Okay, now I'm just going to use this. Right, okay, so I made a change in here. I got to be careful. I got to actually save this. Now, okay, so there's some weird stuff going on here, but don't worry too much about that. Okay, so now if I open names.txt and I add my name again, now I can do the same thing here. And you'll notice that instead of doing add and then commit, I've been doing the shortcut of just doing git commit -a and then m, which if you have a file that already existed, in other words, you didn't create a new file, you don't actually have to separately add it. You can just tell Git, when I commit, I want to just add it directly. But if you created a new file, you have to specifically add it, because otherwise Git won't track it until you specifically tell it to. Sorry?
No automatic updates or anything like that.
So the thing about Git is that in order to give you so much control over exactly what changes you're using and which ones you're not, it's sometimes a little not user-friendly, which is why I'm here, because no one needs to give a presentation on how to use Google Docs.
Well, it depends on the audience.
Okay. No one needs to give a presentation on how to use Google Docs to a bunch of CS50 students. All right. So I mentioned briefly that there are branches. And at the very beginning, that comic that I showed talked about Git having a tree model. So what that means is, let's say that the repository, like the way I have it right now, is the red line. And it's made up of a bunch of commits. Imagine that like some length along that line is equivalent to like a commit, or something like, just there's like a bunch of different commits in there. Doesn't really matter how many. But so let's say that now I have like a working piece of software that's going on in there. Instead of representing our little repository that's just for testing, maybe it's an actual project, maybe it's your final project, maybe it's a piece of software that's like actually being used commercially, when you want to add a new feature, you don't want to break your existing code. So rather than making those changes right in the midst of your working code, you can create what's called a branch. And where the branch starts, everything is identical to in your original branch, which is called master by default. And then as you add more commits, they diverge. And you can end up having more commits on one branch than another. You can even have sub-branches off of other branches. And so if you want to create a branch, and branches can be local, meaning that they're just on your machine, they're just for you personally working on that feature, or you can push them to the remote repository and you and someone else can collaborate on that branch, collaborate on that feature the way that you would on master. So now I'm currently on the master branch. The IDE is smart enough to tell me not just what directory I'm in, but specifically what branch I'm in. So now if I want to create a new branch, the command is a little bit unintuitively git checkout -b for branch, and then the name that I want to give the branch. So I'm going to make a branch called Anna branch. And now it says I'm on Anna branch. And if I look in these files, then you'll see that they're exactly the same as they were. I haven't changed anything by going to a branch. But now let me say that I want to make some changes on this branch. So I have this other file, loremipsum.txt. It's just got a bunch of gibberish words in it. So if I open this, let's say that I want to change the first word to my name. You can do this on your own, and then I save it. Now I'm going to close it so that I don't keep accidentally editing the files when I don't mean to. So now I can commit this. And I'm not going to push this commit. This is just going to be local for now. Because currently there isn't a branch on here called Anna branch. I could create one. If I wanted to share my work on Anna branch with all you guys, I could push, and Git would tell me how to create a branch called Anna branch on the remote repository. But if you're just working on a feature and you're the only one working on it, it's your feature, then there's no particular reason to push it to the remote repository. It can act as a backup. But if you're fairly secure that your computer is not going to die, then there are some advantages to just keeping it on your computer, although I won't go into those unless we have some time at the end. So now I have a branch called Anna branch. And let me just create a file. This is a way of creating an empty file with a given name in Unix. It's just the touch command. So I'm just going to touch a file called Anna. Now you can see that the file's there. Says that there's an untracked file. So now I do have to do git add. And now it knows that this new file exists. On Anna branch, yeah. In just a second, we'll see that when I go back to master, it's not there. Okay. So the command to see the existing branches is git branch, and it shows you which one you're on. There's a variety of other commands associated with that let you do different things to branches, but just git branch on its own will show you what branch you're on and what the other branches are that are on your local machine. So now, to go back to master, I do git checkout master without the -b. You use the -b if you're creating a branch, and if you're not creating a branch, then the name of the command makes a little more sense, because let me go check out master and see what's happening there. So now if I do this, there's no file Anna. If I open this file, you can see that there's no changes to it. And so now I can make some changes over here. So I can, capitalize this, for example. And I can touch another file called master. And so now you can see I have some changes that I haven't staged that are in lorem ipsum, and I have this new file. So now I'm going to add the new file. And I'm going to commit. And again, even though I added one file specifically and didn't add the file that already existed, because I'm using the -a, all the files that already existed will get taken care of. Okay. So now, branches are still there. Anna branch is still there. I could go back to Anna branch and show you that my changes here on master haven't affected that, but I figured you got the idea from when I went to master, and it worked that way. Now let's say that I want to actually incorporate those changes into master. I finished my feature. It's working. I've tested it. It works. And now I want to incorporate that feature into the main piece of software. You finished the simplest version of your final project, but then you actually had a little extra time, so you went back and created this new feature, and now you want to merge it in so that you can actually show it to your TF. Not surprisingly, this is called a git merge, and you saw earlier how you can have merge conflicts, and you're going to have to resolve them. So if I go in here and from master, now I'm on master and I want to merge in the changes from Anna branch. So I'm going to do git merge Anna branch. And it first tries to auto merge. And if there were no conflicting changes, if I had just created the file Anna on Anna branch and just created the file master on the master branch, then it would just do an auto merge and it would commit the result automatically. But if you have merge conflicts, then you have to fix the conflicts before the merge can go ahead. So now, if I go into lorem ipsum, we see the same thing that we saw before, where there's the two different changes. And I can accept either one of them. I can even have them be one above the other if that makes sense for what I'm doing. In code, usually you're going to want one version or the other if you both made changes to that. It seems like there's probably in this interface some fancy way for me to accept one set of changes or the other. But since I don't actually know how that works, I'm just going to try to do this by hand, which is not working out so well. So let me do this the way I do know how, which is in Vim. And let's take the one on master, because my name really isn't that important, that it needs to go in everything. And now, just to show you that that actually did what I said it would, there it is. So now, if I do git status, and you can see it knows that it's in the merge. So because I changed this file that had the merge conflicts in it, I have to add it again so that it knows it's safe to commit. So I'm going to add it. And then I'm just going to do commit rather than putting in a message, because it will automatically generate a commit message that says something about what the conflicts were. Now, merge commit messages are not always super useful, but if there weren't any conflicts, it would just auto-generate that message, and you wouldn't necessarily have a chance to edit it. It would just automatically go into your commit history with this message. Oh. I don't actually know how to, yes. There we go. That's just, it opens it automatically in a text editor that happens to be set as the default. I could have instead done git commit -m and then just an empty quote string, and it would automatically do the merge message without me having to deal with whatever editor it thinks it should use for the commit message. All right, so that was a lot of commands and a lot of just bits of information very quickly. Does anyone have any questions? I know that most of you don't actually have it up and running, but.
So does the Anna branch still exist at this point? You've merged Anna branch into master, but Anna branch still exists, right?
Yeah, so if I do git branch, so the question was, does the Anna branch still exist now that I've merged it into master? Yes, it does, but I can delete it. So the typical thing is, yeah, if you've created a feature branch and the feature has been completely merged into master and you're not planning on doing any more work on that feature, if you created a new feature, or if you wanted to start creating a new feature, you would create a new branch just for the sake of cleanliness and organization. So now what I can do to delete that branch is git branch -d Anna branch. And if I hadn't merged in Anna branch before I tried to do that, it would give me an error saying that Anna branch is not completely merged. In other words, the changes that were on Anna branch aren't anywhere else. So if you delete the branch, you'll lose those changes. But because I had just merged it, Git's smart enough to know that Anna branch is totally incorporated into master. And it is actually possible to delete a branch if you really do want to throw away your changes. It's possible to delete a branch that isn't merged. All you actually have to do is change the lowercase d there to an uppercase d. But it's generally not a good idea, which is why you get an error if you try to do that. Other questions?
So if you had test and production environments, how might you relate branches to those?
So if you had test and production environments, how might you relate branches to those? So this was just an example of a branch that's for a feature and then you get rid of it once it's merged. Yeah. It's also possible to have long-running branches that you use for some part of your development process. So you might well have a test branch. And there's all sorts of ways to integrate other services to hook up and interact with Git. So you could have your test branch automatically run tests on that code. So like you have your development branch, and then you have your production branch, and you have your test branch, and you would take your changes from the development branch, somehow incorporate them into the test branch using some workflow, which might be a merge, like I just showed. And then you would, from there, it would run tests. You could have it set up to do it automatically even, and then you could incorporate it into your production branch. Does that answer your question? Any other questions? Because from here, we go from standard, Git commands that you will certainly use anytime you are trying to do a project in Git to something that's a little bit more esoteric and more like another way of doing some of the same things that we've already talked about. No, like more unusual, like. Okay, so is everyone fairly clear on this? On what has happened so far and like why this is how we would do things? Does that make sense? Okay, excellent. All right. So instead of merging, or sometimes in addition to merging, there's another way of incorporating changes from one branch into another, and that's called rebasing. And it's almost like the opposite of a merge. So rebasing is different from everything we've talked about so far because it actually rewrites your history. And some people think that this is something you should never ever do in Git, but this is a feature that Git offers, so I am of the opinion that it is perfectly fine as long as you know how to do it correctly. It is definitely the case that you should never rewrite public history. So this is what I was talking about earlier when I said there are some advantages to having a branch that's only local on your machine. That means that you can use tricks like this, and I'll go into a little bit more why you might want to do this in a second. But just massive disclaimer to start with, never rewrite public history, because you saw earlier what happens if you don't do the merge correctly when you pull. If you rewrote, if I had rewritten the history and then you were trying to pull, Git would be going crazy with 1,000 errors saying, there are commits missing here that you have, but then there's other commits that you don't have that are here. And so it would think that everything was supposed to have already happened. It wouldn't match what was on your machine. Don't ever do that to your collaborators. Never rewrite public history. But you can rewrite local history, and there are some good reasons to do that. So first, what happens when you rebase? Let's say that I have the master branch in red and then the blue branch in blue. While I am on the blue branch, I could type git rebase master. So it's sort of the opposite direction from merging. I'm rebasing onto master, and it literally means that I'm taking the commits that I made on the blue branch and putting the end of master as their base. So essentially what it does is it incorporates all the commits that have happened on master since the branch point as if they had happened before all the commits that are on the blue branch. Does that conceptually make sense? So the main reason to do this is that it lets your commits actually sort of, an individual commit can be a unit of work, and that can be clear in the history. And you don't have these merge commits where it's not obvious what features were being merged or what changes were actually made, because you don't have access to the actual commits that were made before the merge, right? It's not always obvious from the logs, which actually that's something to look at. If I do this, you can see the log. The command is just git log, and you can look through all the previous commits. So you see there's another merge commit in here. This is what happened when you were having trouble pulling and pushing earlier. So this, some of these are pretty clear. These messages that, I added a file, Scott put his name in the file, things like that. But then we have these merge commits, and it's not really obvious what's going on. Rebasing lets you avoid that. So even if you still want to merge, even if you still want to do the exact same thing, you can avoid having a merge commit because let's say that, so let's do this. I'm going to create a new branch, and now I'm on this new branch. And I'm going to make some changes in here. Just create a new file. All right, and now when I merge, so I'm still just going to merge the normal way. I'm going to go back to master. And I'm going to merge new branch. And you'll see that it says fast forward. That means that there were only changes on one side of the merge. So it doesn't have to worry about which changes should I accept. It doesn't even have to auto-resolve conflicts. It doesn't even have to think about whether there are conflicts, because it knows commits were only added on one side of the merge. So I can just move the head of the other branch up to after those commits. So what you can do with rebasing is ensure that all commits that all merges are fast forward merges. So if you have a local branch just on your computer, and you've made a bunch of changes in there, and other development is going on master. All of your collaborators, all of your coworkers, all of your project members have been making their own changes to master. Maybe they originally started their changes on branches, but then they've merged them in or something. But change has happened on master. And you're working on a feature, and it's in a completely separate file, so there's no conflicts. You can rebase your branch that's just local to you onto master, so that then when you merge it in, you don't have to worry about any of this. It's just a fast forward merge. And it doesn't even create a merge commit. It literally just says, okay, I can put all these commits in this branch as well. Does that make sense? Does it make sense why you'd want to do this and how you'd want to do it?
So in other words, you're saying, take all the work that's been done in the master branch and then add my stuff onto the end of that.
Yes, exactly. So this might seem a little silly because it's mostly about aesthetics. It's also a little bit about making things clearer, but it's not making a big difference to how you actually write your code. Something that can be more useful in regular practice is when you're doing git pull, you can add this option to it. So because I did a bunch of stuff, I have a conflict, but when I do a pull, when you do a rebase, you can have conflicts just like you have in a merge, and you can resolve them the same way. But so the basic idea is that when I do this, it says first rewinding head to play your work on top of it. And it's going to, it's literally going to move back. It's going to take all of the commits that I just pulled from wherever I pulled them, from the remote repository. And then it's going to play my new commits on top of it. In other words, it's going to apply all the changes. So if I just fix this, Interesting. Maybe that's a system difference. So okay. So the basic idea is that now if I look at the log, I'll see that this added my name again. So this was actually not before. Sorry, I made this. Wait, I'm a little confused about the order here. But essentially the idea is that there were some commits that were on the remote repository that hadn't been made here. Something that I had pushed. It looks like maybe I accidentally pushed from Anna branch. But in any case, when I pulled any commits that were, see, at some point I accidentally pushed from Anna branch because I have the commit added file Anna. And you'll notice that that is now in there before. Oh wait, no, that's from the merge. Sometimes this is a little hard to reason about because I'm actually not sure why it gave me conflicts there. But the basic premise is that if I had a bunch of commits, if other people had made a bunch of commits to master and they'd been pushed to the remote repository, and I had some local commits that I hadn't pushed yet, and I do git pull --rebase, then when it pulls, instead of trying to merge, it'll try to rebase. And the only difference is that then you end up with a cleaner commit history, and in this case it actually makes a lot more of a difference, because if every time you pull you're introducing a merge commit, then it starts to get really ugly really fast, and it gets very unclear what you're actually doing. So I wouldn't necessarily suggest that you start trying to rebase all your branches instead of merging them or before merging them. But I would definitely suggest that as you're doing this, you maybe try to get a feel for git pull with the rebase option, --rebase, because that will go a long way towards making your commit history clearer, making it more obvious what you're doing. Okay. Does anyone have last questions before we just finish up? Yes?
Do you, like, as a convention, always use Latin as filler text?
That's not my personal convention, but it is sort of a convention more generally. And I don't think it's actual Latin.
Lorem ipsum translates to it remains.
Yeah, so some of it is real Latin, but it's sort of like,
It's for proofreading. It's
yeah.
been used for proofreading for years, that full text.
It's supposed to make everybody not pay attention to
Yeah.
the words, but they
Yeah, exactly.
inevitably they do anyway. What does that mean?
Yeah.
Okay. Okay. Let me see if I can do this correctly. And then the git log should actually show something useful. Okay, now.
I mean, it looked like, no, I don't make that joke. I was going to say, it looked like Greek to me.
Okay. So now, let me see if the git log shows anything more useful. So yeah, this was when I merged, yes. So the change was when I merged the new branch, and I created the new file. And the last time I had pushed, I had I still had my name in the lorem ipsum file. So once I fixed that, then these were applied after, as if they had originally been done afterwards. Does that make sense? If I had set up my branches to originally try to illustrate this concept, it might have worked a little better. But I wasn't sure whether we were even going to get to this. All right. Any last questions?
So what about binary files or things that you may not be able to read? What happens to those?
Yes, it doesn't have to be able to read things to save them to a Git repository. So I happen to have in here a PDF. So all of you, even if you don't sign up for Git, you can use this handout. It's on the repository page. Again, you can read the repository even if you're not a collaborator on the repository. But so I don't specifically edit the PDF format, right? But if I save a new PDF in there under that name, I can commit those changes and push them to the repository. It's often standard practice to not have your binary files live in your repository unless they're going to be, if it's like a build of your application, you probably get rid of it before committing or put it outside the repository, because especially like Git can't handle very large files, or specifically GitHub won't let you upload very large files because it's too much load on their servers. It's also possible to use Git without using GitHub, in which case you might you might be able to keep large files in there if you had your own server. But so that's more an issue of size than of readability. Question?
Can you go over again what the fast forward meant and why it's a wonderful thing? It sounded like it was a
Right. So a fast-forward merge is one where all you're doing is just taking some commits from one side of the merge and putting them on the other. So if you're on master, you haven't changed master at all. You made a bunch of changes in your feature branch, and you merge in the feature branch. Because there were no changes on master, you can think of it as looking actually like this picture, the on the bottom. The red arrow hasn't progressed, so all you're doing is essentially picking this up and now saying, okay, this is just the red arrow. Does that make sense? And it's good because there's no merge commit. You know there's not going to be any conflicts by definition. If there were any conflicts, you'd already resolved them if you did something like this.
If you continue to work with those branches with the after, though, so the red would go straight forward and the blue would still diverge?
So, in other words, if you have a picture like this and you did a fast-forward merge to bring all this stuff up here, it's kind of hard to show it in the way I drew these diagrams because you would have still two separate branches, but they would have they wouldn't have diverged yet. You can think of it as basically like if you have a red arrow that goes all the way to here, but it has like a red and a blue arrowhead, and so you can add more commits on either of them, and then they'll diverge again, but they're the same up to that point. Any more questions? All right, well, thank you very much.